In this video, we will solve an optimization problem which includes a trigonometric function. Imagine it's summer and you are on holiday with your friends at a lake. But it's not a normal lake, it's a mathematical lake which is circular. In the morning you went for a walk and had a swim. At noon, you're sunbathing on the exact opposite side of your holiday home when your friends call you. The vegan steak is on the barbecue and is ready in a few minutes. Come and join us. You want to join your friends as soon as possible. You know the lake has a diameter of 800 meters and your swimming speed is v. When you're walking around the lake, your speed is 2v. Now, what's the fastest way home? To start, we want to calculate how long it takes when we walk or swim all the way. In addition, we will calculate how many percentage of the time from the longer option we would need for the shorter one. In the second part of this video, we will check whether we are faster if we swim one bit and then walk the remaining part. For the time calculation, we need the distance and the speed. So t swim equals distance swim divided by velocity swim. The same applies to the walking. Additionally, we know that we are walking twice as fast as swimming. So we swim equals v and we walk equals to 2v. Next, we have to calculate the distances. We swim across the lake, so the swim distance SS equals to 2r. Now we can insert everything into TS and get 2 times r divided by v. Now to the walk distance. The circumference of a circle is 2r pi, but as we only walk around half the lake, we only need half of it. Again, we can insert this into the time formula t-walk. Now we rearrange it, which gives us r pi divided by 2v. Calculated, we get 1.57 times r divided by v. That's less than swimming. For swimming, we need 2r divided by v. Although we don't know the absolute time, we know it depending on the radius and the swimming speed v. Swimming is the longer option and therefore 100%. Now what percentage of the swim time is the walking time? The formula for calculating the percentage is p% equals part divided by whole. For us this means time walk divided by time swim. Next we insert the formulas and reduce. That gives us pi divided by 4, which equals 79%. So walking takes only 79% of the time needed for swimming. Actually, the way to walk is exactly pi half longer. To be as fast as swimming, the runner must be exactly pi half faster, which is about 1.57. But we walk 2 times the swimming speed, so we are faster with walking. In the second part, we will calculate with radians. This will simplify the calculation and make it easier for us. As a short refresher, this animation explains the radians in a nutshell. That's a unit circle with the radius equals to 1. Now to the task. We are currently at point A and want want to go to point B on the opposite side of the lake as soon as possible. The options of walking or swimming have already been discussed in the first part. But now we can also swim a part, for example up to point P, and then walk the rest along the lake. The ratio between swimming and walking is determined by the angle alpha. Alpha describes the angle from A to the midpoint to P. So the distance we want to swim. The distance which we are going to walk is described by pi minus alpha. This because in radians pi equals to 180 degrees. We will calculate the swim time as well as the walk time as a function of alpha. Then we will sum them up to get the total time needed. This formula will then be optimized. So let's start with the walking distance. Many of you know the formula for the arc length in degrees. Pi times r times the angle in degrees divided by 180. We will therefore proceed on the basis of this formula. We replace 180 with pi and then reduce. Thus you get the arc length in radians. R times the angle in radians. But our angle for walking is not gamma, but pi minus alpha. And so we already have the walking distance. The walking speed is still 2v. Also the walking time equals still walking distance divided by walking speed. Therefore we insert this into the formula and multiply it. Now to the swimming distance. Imagine we cut out the triangle A to the midpoint P. This is not a right-angled triangle and therefore it's difficult to calculate the side SS. But we can cut the triangle in half in order to calculate half of the swimming distance. We know the hypotenuse r and the angle alpha half. SS half is the opposite. Therefore SS equals sine of alpha half times r times 2. Otherwise we would only calculate SS half. Speed and time calculation are still the same. Therefore we can insert and get the swimming time. So finally we have everything we need to calculate the total time in dependency of alpha. T equals walking time plus swimming time. So let's insert that. We want to keep the time as short as possible. Therefore we want to optimize t. To do so, we have to take the derivative and then find the zeros. The derivative of the first two summands are 0 and minus r divided by 2v. For the sine we need to apply the chain rule. The derivative of sine is cosine. Alpha half stays in the cosine. But the derivative of alpha half is 1/2 and then multiplied. R divided by v is a constant and can be left as it is. Now we have to find the zeros. We solve the equation to alpha. After several steps we arrive at alpha is 2 times arc cosine of 0.5. At this point, don't forget to change your calculator from degrees to radians. Otherwise, the result is useless. That gives us 2/3 pi, which equals 120 degrees. So finally, we found the minimum. Well, Are we sure about it? Let's check the graphic device. We are only interested in the range from 0 to pi. Green is the function and blue the derivative. At point A, alpha equals 0 and corresponds as if we walk all the way. For this we need pi half time, as we calculated in the first part. At point C, we swim the whole distance, because alpha equals to pi. For this we need the time of 2. Also this we have been calculating in the first part. D is our optimized time, but it's not a minimum, it's a maximum. That means we reach our friends fastest when you walk around the lake. Just swimming is not the slowest, but not as fast as walking. But what makes nonsense in regard to time is to split the route in 2 parts. Expect if we swim only a short bit. Next we do the test with which we would have found out that it is a maximum. For this we take the double derivative and insert alpha, so 2/3 pi. This gives a negative result and therefore, as expected, a maximum. The emoji as a mnemonic. Finally, we calculate the time at the maximum. We get about 2.26 r divided by v, and as expected, the longest time. At alpha equals 0, we are the fastest. That means if we walk all the way. At alpha 2/3 pi, or 120 degrees, we have the longest. So the vegan barbecue should now no longer have to wait. Let's have lunch.